exponential equations. So we need to recall what are exponents. Exponents are, if you recall, when I have a power of 2 to a base of 2 to a power of 2, that tells me I have to take the base 2 and multiply it by itself twice. So I get answer 4. Now here comes a question where 2 to the power of x is equal to 16. So this expression is asking me for what exponent of a base 2 will give me 16. Well, I know that 2 times 2 times 2 times 2 will give me 16. So I could have rewritten 16 as 2 to the power of 4. So when I put this with the left side of the equation, 2 to the power of x, therefore I know that x has to equal 4 in order for the equation to be accurate. So let's create steps of how to solve exponential equations. The first step I'm going to tell you is that you need to make the bases the same. And when I choose what base, I have to know some of my perfect squares. So 2 times 2 is 4, 4 times 4 is 16, 3 times 3 is 9. So use the ones you know and try to make the bases the same. When you're choosing the bases, always try to also choose bases that are the simplest one. 2 and 3 are good bases. 4 times 2 does give me 16, but I'm not going to choose 4 because 4 is not the smallest base I can get. And it's best to work with the smallest. The second step would be, so once the bases are the same, so for example this step here, 2 to the x equals 2 to the 4, the bases are the same, so now I just know that the exponents have to equal. So now I can just make the exponents equal. With an equation. Okay? Sometimes it's not going to be just as simple as an x and a 4. Sometimes you may have, as in our example later on, x minus 1. So we need to make the whole exponents equal to each other. And then the third step is to solve for the unknown. Okay? So the unknown variable. So let's go through 2 examples and apply these steps. Here I have an equation. 4 to the power of x equals 8. Like I said, right now 4 to the power of 2 will not give me 8. It will go beyond 8. So this is where I was talking about where you have to try to make bases that are the same but as small as possible. So I know that 2 to the power of 2 does go into 4. But that just replaces the 4. I still have my x, if you recall. So I replaced 4 with 2 to the power of 2, but I still have it to the power of x. On the left side only. On the right side, I know that 2 to the power of 3 will give me 8. So now, if I look at the left side, it's a power of a power. I have 2 to the power of 2 to the power of x. So power of power tells me I have to multiply the exponents. So 2 to the power of 2x is equal to 2 to the power of 3. So therefore, the bases are now the same. I can make the exponents equal with an equation of 2x equals 3. Now to isolate and solve for the unknown, I have to divide both sides by 2, and therefore I get x is equal to 3 over 2. Let's try b. b, I know that 2 to the power of x minus 1 is the smallest base I can make it. 2 to the power of 7 will give me my 128. Now that the bases are the same, I can make the exponents equal. So I just have x minus 1 has to equal 7. So now I have to solve for the unknown, so move the negative 1 over. I got x equals 7 plus 1, so x is equal to 8. Follow these steps and you can solve for an equation.